All right. So there we go. Tell whether this is nice and easy, but there's 25 of them. Tell whether it is true or false. So let me write a little bigger here. They have this weird E thing, and then they have curly brackets. Anybody know? Anybody seen set notation before? You know what that weird E thing is there? It's E. It stands for element of. And this is a set. So they're saying, hey, 9 is an element in that set. No, it's not. False. Next question. So they're making a statement. They're saying 9 is in here. No, it's not. Make sense? So it's actually a Greek E. It's epsilon. But anyway, it stands for element of. It stands for element of. So we're getting so we're totally changing gears now. We're in a whole different math world now, probability and sets and stuff. So there's going to be a new language they speak here. So I'm letting you know that little weird looking E thing means element of. Element of. So that was a false statement. 9 is not an element in that set. Okay, that one says 3. 3, 5, and 8. Okay, so is that a true statement or a false statement being said up there? Well, what does it mean when there's a slash through a symbol, do you think? Not. Not, right? It means opposite. So what they're saying, here's the words. Let me put it in words. Here's the words they're saying. 3, and what is that? It means not element, right? Not element of that. They're saying 3 is not an element of that set. Are they right? No, they're wrong. 3 is an element of that set. That's another false statement. You okay with that? They're saying 3 is not an element, but it is an element. So whenever you slash anything, it means not, right? All right. Okay, so they got a bunch of sets there. I don't know if you can see them all. I probably should have made them bigger. But all they care about is C and D. They're saying, look at set C, look at set D. Are they equal? No. No, that's a silly question, huh? No, they don't have. By the way, the order of the stuff doesn't matter, but the stuff itself matters. So no, one of them's got numbers, the other's got letters. No, they're not the same. That was a silly question. Determine whether, number 4, determine whether the following statement is true or false. All counting numbers not greater than 3 equals 1, 2, 3. Is that true? Is this really equal to that? You got to know what a counting number is. Of course, that's pretty obvious. Now, what numbers do you count on? Where do you start counting? Do you start with -5? No, we don't. Where do we start? 1, 2, 3, right? Counting numbers. So the counting numbers start at 1, 2, 3, 4, 5. On you go. Those are what we call the counting numbers, just like what you count on. Whoops. Okay, counting numbers. Okay, and they're saying, give us all the counting numbers not greater than 3. Which ones are not greater than 3? Let's go one by one. Hey, 1, are you a counting number not greater than 3? Is this too tricky? 1 is not greater than 3. Hey, 2, how about you? Yeah, I'm not greater. Hey, 3, are you not greater than yourself? Yeah, I'm not greater than myself. I'm equal to myself. So it's right. 4, 5, and 6, they're greater. So yeah, that's true, isn't it? That's a true statement. The numbers that are not greater than 3 are 1, 2, and 3. The counting numbers not greater than 3 are 1, 2, and 3. Notice we're not counting decimals. No 1.5, no 1.5, no negatives, and no 0. That's why they say counting numbers. If they just said numbers, well then no, deal's off. There's all kinds of other numbers. Decimals, negatives, zeros, pi. There's a zillion other numbers. But if they say counting numbers, then yeah, okay, that's true. Just counting numbers, right? Symbol here. We have the set on the left. We have the set on the right. Let me make it a little bigger here. So -1, 0, 8. This is curly brackets that I'm making, which is set notation. 5, 6, 3, 4, -3. The order of the elements in the set doesn't matter. So anyway, do you guys know what it means when you do like that? That's not the E. This is a different symbol now. It's not the E. It's like a sideways C with a line underneath it. Does anybody know what that means? For set notation? You guys done much set stuff? C means contains. And you know what the bar in the bottom anything means, or equal, right? Bottom line means equal. So where they're saying this set here is contained in or equal to that set. Is that true? Is that true? Is this set contained in here? Is all the stuff in here found in here? No. So slash. This is the one that's true. Not contained in. Good? So we have a couple symbols now. We have element of. That's just for one piece, right? One element, right? That'd be like saying one person is in there, right? Destiny is an element of this class. Versus saying Joel and Destiny, they're a subset of this class. Yeah, that's the other thing. It means subset. This also means subset. Sub-collection. Contained in. All right. Before. But you know what it means? What's the 0 with the slash through it? What is it? Not 0. I don't know. It should be not 0, huh? But it's not. It's not 0. It's the empty set. So it's like this room after we all leave. It's an empty set. It's a collection of nothing. No people, anyway. Yeah, that's just... No, you can also do it this way. You can do curly brackets and put nothing in there. That's the same. This and this are the same. There are two ways to say the same thing. You can either draw an empty set, or you can do 0 with the slash. I don't know why that caught on, but 0 with the slash is a symbol for empty set. So what they're saying then is they're saying the empty set is contained in here. Well, yeah, it's true. The empty set, like right now, if we all left, the empty set would be in here, wouldn't it? So it's really in here with us, right? Does that make sense? The empty set is a subset of every set, is how they say it, right? You could have emptiness in there, right? You have 3 items. The empty set is a subset. All right, it's contained in there. The empty set is contained in there. Subsets. So if you have A, B, and C, so I'm just going to write them without the curly brackets. If you have A, B, and C, how many subsets? Now, what is a subset? It's like a sub-collection, you know? Like you're picking people out of the group. So you got people A, B, and C. You got A, B, and C. Say, all right, I'm gonna pick a sub-collection. So what are all, now be as thorough as you possibly can. If you were going to pick a sub-collection of A, B, and C, what are all the different ways you could pick a sub-collection? First, you could pick them all. I'm going to take them all. Say these are candies. Say these are like sour, lemon, and lime or whatever, like that candy problem. If somebody offers you 3 candies, hey, I got a sour, lemon, and lime. Say, I'll take them all, thank you. That's one thing you could do. Or, what else could you do? You could take just the first 2, just the first and third, or just the second and third. So far, 4 different things you can do, right? A and B, A and C, B and C. Are good so far? What else could you do?
One of each?
Yeah, you could just say, I'll just take candy A, please. I'll just take candy B. I'll just take candy C. There's one more thing you could do. You could take nothing. That's what we mean by it's a sub-collection of every... It's always a possibility. I'll take none, thank you. So there's 8... That's surprising, huh? There's 8 different things you could do. Next time somebody offers you 3 things, you'll think, there's 8 things I could do here. There are 8 things I could do. It's amazing. But there are 8 different things. Yeah. Now, let me give you the rule. Having done that all by hand, number of subsets, there's a handy little rules. Anybody have any idea? Anybody seen it before? You know it?
2 by the number of how many sets?
Nice. You just come up with that?
No, I learned it in stats.
How was your chance to say, yeah, I just figured it out, Mr. Heron?
Oh. Okay.
No, good. I appreciate your honesty. Yeah, stats. It is. It's 2 to n. Or where, maybe if that helps to put number. 2 to the number. Yeah. So in other words, see what I mean? We had 3 items. So if you take 2 to the third, what do you get? 8. You see that? It's always 2 to whatever the number of items. It's 2 to the number of items. So the number, I'm not writing that very clearly. Here, let me try this again. Whoops. Number of subsets is 2 to the number of items. So the number of subsets is always 2 to the power number of items. Right, so if we have 3 items, it's 2 to the third, which is 8. Sure enough, there's 8. So if somebody offers you, if somebody offers you 4 things, how many different things can you do? Two to the fourth, right? They offer you 4 things: lemon, lime, sour, and grape. Right? Now, after you 4, you could do 2 times 2 times 2 times 2. 16 different things. I don't want to write them all out. But there are 16 different things you could do, including taking them all, taking none, or some amount in between. Get the idea? Why is that, by the way? Why is it 2? Where'd the 2 come from? Why does that work? Why is it 2 to the number of items? Because you think about it, every item, you've got 2 options. If you look at the 3 items, let's go back to the 3. With the A, candy A, we can take it or not take it. Candy B, take it or not take it. Candy C, take it or not take it. 2 options times 2 options times 2 options. That's why. That's really what's happening. Okay, want to try that one? Find the number of subsets for the set. First off, you've got to find the set itself and how many things are in there. Hey, that's not very clear. What do they mean between 3 and 7? Do they mean including the 3 or not? That's not very clear. I don't like that. Yeah. So when they say the words between, they're not including the 3 and the 7, which I guess that's technically what it means. So M is 4, 5, and 6 only. Good so far? So when they say, what are all the numbers between 3 and 7, they mean 4, 5, and 6. So it's like somebody offered me, hey, do you want 4, 5, or 6? Which is weird. Why would anybody say, they wouldn't assume say that. Sounds like Sesame Street or something, huh? Today is brought to you by the number 4. So, do you want 4, 5, or 6? So anyway, whatever. How many subsets? Remember, they want me to figure out how many subsets. So how do I figure out how many different things I can do? How many sub-collections? It's 2 to the power of 3, because there's 3 items, so it's 8. Done. So that's what they want here. 8 subsets. There's 8 different sub-collections. So when there's 3 items, it doesn't matter if they're 3 numbers or 3 candies or 3 whatevers. There's 8 different things you can do. 2 to the third. Does anybody know, what does complement mean? So U is the set of all integers, and M is an integer between 5 and 31. Find the complement of M. How do you find the complement? What's the complement of M? Means you say, M, you're such a great set. I'm kidding. You don't. That's not what complement means. It means opposite. Opposite. Complement means opposite. Complement is opposite. Opposite. Okay, so what is M then? It says it's all the numbers between 5 and 31. So basically it's 6 through 30, isn't it? You with me so far? M, they said, is the numbers. Integer just means not the decimals. Integer just means we're not counting decimals. We're not counting, 6.3 and 7.9. Just the whole numbers. Between 5, they said between 5 and 31. So that means we don't include the 5, we don't include 31. So 6 through 30, in other words. That's M. So what's the opposite of that? Well, the opposite, which is complement, Complement, which is opposite. That'd be 1 through 5 and 31 on. Huh. Oh, wait a minute. My mistake. Integer includes the negatives also. So that'd be 5 or less. Anything in 31 or more, wouldn't it? There we go. 5 or less, including negatives. 31 or more. So which one of those says that? It's D, actually, isn't it? See how that's less than or equal to 5, greater than or equal to 31? It's D. Can you guys read that? Maybe I should have made that bigger. Is that okay? Can you see that? All right, I better move on. All right, B and C. Yeah, what do you think? So they give me some options here. Oh, these are some things I haven't told you about. Oh, no, it's not these. We'll get to these in a minute. Oh, no, it is those. Okay, no, never mind. See, we got to talk about those. Yeah. Do you know what, like if I have, let me give you an example. If I have 1, 2, 3, 4, 5, let me just give, and I do like that, that means overlap. 3, 4, 5, 6. Do you know what is the overlap? Notice what are these? This means overlap, right? It's the U turned over. Oops, kind of scribbling it all up. Come on. So it means overlap means what do they have in common? See how this has 3, 4, 5 and this has 3, 4, 5? We're saying who's in, like if those are classes, this is an English class and a math class, saying who's in both classes? Who's in the English class and the math class? 3, 4, and 5 are in both classes. They're overlapping. So that would be the answer, 3, 4, 5. That's what we call by the overlap. Whereas if you do 1, 2, 3, 4, 5, you with 3, 4, 5, 6, what's that mean? That means unite. That means the two classes come together, have a party together, or whatever, right? They get together and have cookies. So that means they unite. So the U turned up stands for unite. That just means, hey, everybody get together. So if you say, well, yeah, but some of the people are in both classes. Right, well, they're not going to show up twice, right? So it would just be 1, 2, 3, 4, 5, 6, wouldn't it? Does that make sense? See the difference between union, uniting, the U turned up, and the U turned down, overlap. So those are the new symbols. So this, when the U's turned over, it means overlap, like who's in both classes. Who's taking the English class and the math class, 3, 4, and 5 are. And U means, hey, let's get together. Let's have the English class, math class get together, have cookies. Who shows up? Everybody, 1 through 6. 1 through 6. But you never list anybody twice. You never list an element twice. Right? When I say right, I mean like if I was calling roll for the class. Right? I wouldn't say Alexander twice. I wouldn't say Alexander's here, and Alexander's here. Right? Alexander's here. We don't do them twice. So sets just mean who's in. We never list them twice. And the order doesn't matter. You could rearrange the order however you want. It's just about whether you're in or not in. Good so far? So which one of these is correct? What needs to go in the middle of B and C to make it equal 8, 12? It's overlap, isn't it? Because 8 and 12 are in both classes, aren't they? That's the overlap. Good there? All right. Oh, you might think it's element. The reason it's not element just means one thing, not two. So it's not. That's why it's not element. It's this one, unite. That's crazy. I'm just trying to go quick here. All right, one more time. I don't want to leave it on record the wrong way. There, it's A, overlap, right? All right. Bless you. Okay, so there they give me the set 16, 18, 20, 22, and they want me to put some symbol in there, either U, unite, or overlap, with the empty set, with nothing, to equal this. So what do you need to put in the middle there? If you put overlap, it's wrong. Why? Because that means overlap, like what's in common? Who's in both? Well, there's nobody in the empty set, so they would have nothing in common, right? The empty set has nothing in common. So it's unite. It's, hey, this class gets together with nothing, and it's them. Which is kind of a silly statement, but it's true. Okay? Math, we're into truth wherever it may be found, even if it's kind of meaningless truth, which can be a little goofy at times. But okay, that's technically true, but weird. All right, so we have set A and set B. They're doing the overlap, aren't they? So they're taking set A, set B, and they're overlapping them. Can you give the answer to that? Yeah, it's whoever, is that what it is? Yeah, whoever's in both. I can't tell. It's like 5 and 9, 5 and 9. Yeah, nothing else, huh? So that's it, 5 and 9. Done. Is that okay? The U turned over means overlap. Who's in both? All right, moving on. So let me show you. Yeah, so they're saying here's A. Oh, U stands for the universe. So the universe, the everything possible in the little problem you're looking at. So it's a small universe. So the whole universe in this problem is just 9 through 15. That's like the only numbers we're going to consider as possible. So they make a universe for different problems. So if that's the whole universe, and A is 10, 11, 13, and 14, they're asking me, what is A with that little mark up there? That means opposite. It's called complement, as we said before. Some books put a bar. Some books use that. That's another way that different math people will write complement. So if a bar or a little mark, either way it means opposite. So what's the opposite of A? What's everything that's not in A? Yeah. Well, get rid of 10, 11, 13, and 14. What else do you got? 9 and 15. Those are the ones that are not in A. But they're still in the universe. I can't do any numbers outside of the universe. Is that making sense? Kind of goofy, right? It's like, what in the world does that have to do with the real world? Not much yet. We're training with the hammer right now. We will build a house in a little bit, but we're just getting used to swinging the hammer of set logic right now. It will have a purpose in a little bit. What's that?
12.
Oh, did I miss one? Oh, I missed one. Thank you. I'm going too quick. 12, yeah. Thank you. 9, 12, 15. Thank you. I just missed the 12. Yeah. Yeah, thank you. Everything not in A. Good? Okay. So they're giving me the universe, which is A, B, C, D, E, F, 16, 17, 18, 19, 20, 21. Here's X. Here's Y. They want me to find X complement intersect or overlap with Y complement. A little more work now. Let's do it piece by piece. Let's find X complement, or not X is another way you can say that. The opposite of X. So what's the opposite of X? What is the stuff not in X? Well, X has A, B, C, so that would be C, D, E, F. C, D, E, F is not in X. And X has 16, 17, 18, so that would be 19, 20, 21. That's not X.
We have C. X would have C. It's in the universe.
Oh, wait. I shouldn't have C, should it? Yeah, is that what you're saying? Yeah, you're totally right. I'm messing up. Yeah, thank you. Yeah, X has A, B, C, so I should start it at D. Thank you. Good? So that's not X. Yeah, I'm messing these up today. And let's do not Y. So what's not in Y? Well, Y has B, D, and F. So what's not in there is A. So watch me if I do this wrong. C, E. Right, so far? I'm doing the ones not in Y. And then what numbers? Well, it has 17, 19, 20. So it's missing the evens, huh? 16, 18, 20. That was easy. It's just the evens. Okay. So there's not X. There's not Y. Now what am I supposed to do with them? What's in the middle of not X and not Y? Overlap. They want me to do the overlap, right? That's what's right here. Overlap. So what's the overlap between not X and not Y?
E and 20.
Yeah, they both have E. They both have 20. Is that it? Anything else? I guess that's it, huh? E and 20. That's the overlap of not X and not Y. See how we did that? right. Okay, so they want, here's D, here's E, here's F. They want me to first have, oh, you always go where the parentheses are first, don't you? You know that from math stuff. So first off, do the parentheses first. They want me to do D unite E. So that's the U turned up. So let's do that first. Let's do D united with E. Let's start with that. So that means we're going to take set D, and we're going to take set E, and we're going to say, hey, get together for cookies, right? Just unite them. Just put them together. So that would be all of D and all of E. I'm going to try to put them in order. So it'd be 12, 14, 15, 16, 17. I think I did it, right? That's, you don't list anybody twice, right? Just 12, 14, 15, 16, 17. Good so far? So that's that. We know F. We've already got F. Let me just rewrite it over here. 11, 13, 14, 15, 17. And what are we supposed to do between these two? Right? It's the overlap. Right? So this is D, unite E, overlap with that. So I'm supposed to take this, overlap this. See the final step there? How do I do that? How do I overlap them? Is there anything? 14, 17, I see. They both have 14, they both have 17. Oh, 15. Anything else? No, that's it, huh? So 14, 15, 17. That's a 17. That's the answer to the overlap. 14, 15, 17. So you do these step by step. Step by step. How are we doing on time? Am I getting lost in time here?